Let's use the apply operator to reshape reality one query at a time. Welcome to this video on the apply operator. My name is Kevin Fiesel, and I am the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. We are nearing the end of this series on how to use the apply operator. But before we wrap things up, I want to show you a pair of additional use cases for the operator. I'll show you how we can reshape data sets using the apply operator, including unpivoting and getting the largest or smallest value from a range of columns. SQL Server has built-in functionality for both of these, but I believe it's always good to know multiple ways to solve a problem. With that in mind, let's go to the demo and see a few things. Here we are in Visual Studio Code. In this video, we are going to look at two ways of using the apply operator to reshape data. My first demonstration involves unpivoting data. Unpivoting is when you take a wide table and you reshape it into a tall table. That is, you consolidate the attributes of an entity. I'm going to start things off with the financial metrics query that we saw in the prior video. I won't explain what each measure is and how we derive them, as I did that already. So if you need a refresher, or if you haven't seen it yet, you might want to check out my video on simplifying calculations using the apply operator. Anyhow, you can see a perfectly reasonable result set here. I have 95 records and a series of numeric measures. Let's suppose that I would like to extract any of these numeric values that are above 0. As such, I'd like to create a new result set that includes the calendar year, calendar month, the name of the attribute, and its value. Let me show you one way to do this using the unpivot operator in T-SQL. This query starts off the same as before with my common table expression to retrieve orders information. From there, I create a new common table expression and call it pivot vals. Inside of pivot vals, I have my original base query with one important modification. I must explicitly convert each of these columns into a specific data type. In this case, I'm converting everything to a decimal with 16 total digits and at most 2 digits after the decimal point. If I do not include these explicit casts, the unpivot operator will fail later on. Now, I'll scroll down to my new base query. Here, I derive from the pivot vals common table expression. Then I use the unpivot operator and say that I would like to create two new columns. The metric will specify the name of my attribute, and value will contain the numeric value of that attribute. We specify the attributes we want to include here, and then I filter them where value is greater than 0. Let's give this a run and make sure that it works. It does, and we get back 760 rows in total. But I'll let you in on a little secret. When I created this query, I had to look up the unpivot operator syntax. That's because the syntax of pivot and unpivot are kind of awkward and have trouble sticking in my brain, and I'm definitely not alone here. With that in mind, let's see how the apply operator version works. This query starts off the same as before, with my orders common table expression, followed by a pivot vals common table expression. But the first thing to note is that inside of pivot vals, you can see that we do not use the cast function to convert data types. With the apply operator, SQL Server will perform implicit conversion. This is our first improvement over the unpivot operator. Less work needed on our part, assuming we aren't strict about how the final query output looks. Then, in my base query, we start with pivot vals and use cross-apply in a new way, using the values clause. The values clause allows us to build out virtual tables. We take the input of pivot vals and generate 8 new rows for each input record. In each row, we define the metric and then specify the measure we would like to use. Finally, we alias this operation as U and label the columns as metric and value, respectively. The downside to this is that I do need to specify the names of my metrics and cannot use the column names like we did in the unpivot example. But the plus side is that I can give these columns human-readable names. Also, because most T-SQL developers are familiar with inserting values into a SQL Server table, and that the values clause allows you to insert multiple rows into a table in one go, it's pretty easy to explain. The trickiest part is simply knowing that this is possible. Anyhow, let me run this query and we'll get back our results. We can see that we still get 760 rows back, and SQL Server implicitly converts everything to a numeric value, which happens to have 2 spots after the decimal point. I'd say that's pretty nifty, but it's not the only unpivoting trick we have with apply. Let's move on to the next script. In this case, we have something that is more akin to a classical unpivot operation. I have here a sample table with quantity and revenue values for 2013 through 2015 inclusive. I'll insert some sample data for a few products, just so we have something to work with. Let's suppose that we want to insert this data into SQL Server, but not like this. We understand the rules of normalization and realize that year should be an attribute. I will, of course, show you 3 ways of doing this. The first method is to brute force your way to victory. I know that I have columns for 2013, 2014, and 2015, so I can build out my results a year at a time and union all everything together to make it work. This is okay if you have a small number of years and a small number of products, but it does necessitate 3 separate scans of the sales table. If that table has a billion records in it, or if you have 30 years of data, you probably don't want to do this. The second method involves a case expression and something we rarely see in good queries, a cross join. I'll start with the latter. In the from clause, we drive from the sales temp table, but then cross join to a new virtual table that I build, made up of the years 2013 through 2015. This is a cheap and easy way of generating each year within the confines of a virtual table to which we can join. Then the case expression drives off of the year column. Based on the year we specify, we'll use that version of quantity and revenue. This query will function the same as the prior one, but it will be faster because we only need 1 scan of the sales temp table for it to work. Finally, we have the apply operator version. Here's another example where apply is a lot more convenient and easy to read compared to the alternatives. We have the sales table as before and then create a new virtual table that I can call Y. We build up the virtual table using the values clause and specify, for each year, which column we want to use for quantity and revenue. What's nice about this is that we can contain all of our tedium to the apply operator itself. This helps if we ever need to update the query. For example, suppose we add in 2016 data. How would that affect each query? In the first case, with union all, we would need to add a new union all and a new query. We now need 4 scans of the sales table, making things perform that much worse. Actual development is easy enough as long as you don't forget to change the column names when you copy and paste the select statement. For the cross-join and case expression combo, we would need to update multiple sections. We would need to add a new year to the Y virtual table. Then we would need to update 2 case expressions in the select clause. In a simple query like this, it's trivial enough. But I could imagine messing up a more complicated query due to missing one of these. And for the apply operator version, we add a new row for the new year and specify the columns we want to use. We only make changes in this one section, so no matter how complicated the rest of the query is, we won't miss anything. Unpivoting is one great way of reshaping data, but here's another for you: getting the largest or smallest value from a set of attributes. As of SQL Server 2022, we have the ability to use the greatest and least functions. These return the maximum and minimum of a set of inputs, respectively. Let me first show you how the function works, assuming you have SQL Server 2022 or later, or Azure SQL Database. Then, once we see how it works, I'll show how you can emulate this functionality if you're on a version of SQL Server earlier than 2022. I'll begin with a really simple example, passing in hard-coded values of 1 through 5 to each of these functions. If I run this bit of code, the results are exactly what I would expect. I get 5 for the largest number and 1 for the smallest number. That's as simple of an example as I can create, so let's scale it up a bit and get a little more realistic. For my next trick, I'm going to need the help of a volunteer, and I happen to have one right here in this sales temp table that we've already seen. We're going to have sales data for the years 2013 through 2015. Each row in this temp table will have a product, and then we'll include 3 columns for quantity and 3 columns for revenue. I'll insert some data for 5 products, as I don't need a lot of detail to demonstrate this use case. Once I've created the table and inserted the sample data, we can see that I can use the greatest function to get the largest quantity and the largest revenue for each row. Because greatest and least are not aggregate functions, we do not need a group by clause here for our data. Now let's suppose that you don't have access to SQL Server 2022 or later. In that case, you can still build this same sort of functionality using the apply operator. We'll start with the same temp table and sample data set. Once we have that in place, we can see how to build our query. We start with the sales temp table, then perform a cross-apply operation that I'll alias as QTY. Inside of there, we have the 3 quantity-related attributes that we union together. This generates 3 separate rows, one for each value of quantity. We repeat the same in the next cross-apply operation, getting our 3 values for revenue. Because we are using the same capability as we used for unpivoting data, we're really generating 3 rows for each product. For that reason, in my select clause, I have my product, and then I will use the max and min aggregate functions to get the largest and smallest values for quantity and revenue, respectively. But because I'm using these aggregate functions and I have a non-aggregated column, I need a group by clause with my product in it. Also, it would be remiss of me not to note that you can use the values clause to break our different quantity columns out into separate rows, just as we did in the unpivot example. I think this makes the query a little bit easier to read, though admittedly, greatest and least are still easier to read and understand than either of these solutions. That's all I have to say about the apply operator, for now at least. Over the course of this series, you've seen how some very smart people have come up with clever uses for the apply operator, transforming it from a bit of functionality that might merit a paragraph or 2 in a book on SQL Server 2005 to a versatile problem solver that is extremely efficient for certain classes of query. We've also seen how to make it easier for developers and analysts to understand what's going on in certain kinds of complicated T-SQL queries involving calculations, and how to emulate some functionality that either is not intuitive or might not be available to you depending on the version of SQL Server you're using. As we wrap up this series, I hope you got a lot of value out of learning more about how apply can work for you. We'll have links and show notes in the description below, and until we see each other in the next video, take care.